Hello everybody, Greg is here. Today I want to show you some interesting works about molecular barrels or molecular cages. Depends how you look at them. That's how the artificial intelligence sees a molecular barrel. So I thought it's a nice cover for the video. But let's start from some background about how you form a molecular barrel by self-assembly. So this topic is coming from donor-acceptor chemistry. When people try to understand how molecules self-assemble in solution, they thought it will help them to better treat some viral infection. You know, viruses has those heads which self-assemble in the cells. So people thought that if you understand how molecules self-assemble, it will help them to prevent the self-assembly from viruses, for example. So the self-assembly that was studied was by reacting donor molecules with acceptor molecules, but the reaction can happen only at those ends of the molecules. If you take a donor with this shape and an acceptor with similar shape, it will form this square, because donor can react only with acceptor. The idea worked pretty well, and it also worked pretty well when scientists try to synthesize 3D shapes, like those molecular cages or molecular spheres or molecular cubes. Again, you have a donor, you have acceptor, only the ends of each of those shapes react and the final shape is formed. I'll show some examples with molecules in a minute. The most important thing here is to put the correct ratio of the molecules. So for example, in this one, there's 3 red ones and 2 blue ones. If you put a different ratio, you will not get this structure. And only by designing the different donors and different acceptors, you can reach huge shapes, very complex cage molecules. There was some publication recently about more than 120, I think, parts self-assembled in solution into a nanosphere. And the same idea was also further developed to synthesize molecular organic frameworks, a topic that will sooner or later receive its Nobel Prize, I believe. But let's go back to the molecular barrels. Specifically, this publication in JACS was that pushed me to make this video. This is a review article, so a group from Bangalore University shows recent progress in the field of molecular barrels synthesis and applications with a lot of their own work. I'll just show several examples of those barrels. So this one, for example, forms from 3 different molecules, 2 types of donors which interact with this acceptor, platinum based, and this shape forms due to the template presence in solution. So it helps cell to self-assembly when there is some additional molecule which do not participate in the final structure. So this is a trigonal prism example. Here is a square prism example. Again, different donors with an acceptor. You can control the length of those corners by putting donors with different length. And one more example I want to show is this one. This one more looks like a barrel. Beautiful structure. The authors describe several applications for those molecular barrels. One example is separation. If you take fullerenes of different sizes and only one of them can fit the barrel that you use, so it will enter the barrel, second one will stay outside, and you can wash it out and leave this one inside the barrel, and this is how you separate it without using chromatography. Second idea is catalysis. That's I like a lot. It works in some way similar to how enzymes work. In enzymes you have a reactive pocket where molecules enter, the pocket fits to their shape and brings them together and they react. So something like that happens also here. So 2 molecules fit in the barrel, react inside the barrel, and that actually makes the reaction much faster. And without the barrel, this reaction will not work, or at least not as effectively. And they provide example of antibacterial agent and also a stabilization example. The idea is that in a solution, this molecule is more stable. However, this one fits the barrel better. So in the barrel, this one becomes straight, and you can remove it from the barrel and keep it in the same form after the removal. I also actually saw different publications about stabilization of an explosive molecule in the molecular cage. So there's definitely some potential. However, I promised you to tell something about whiskey aging. And it was not a clickbait. And none of those applications, in my opinion, really similar to whiskey aging. When whiskey is kept for years in a barrel, some molecules from the wood, from the barrel walls actually, they interact with the solution, provide the unique flavor. That's why you use barrels from different wood types. Also, the smaller is the cask, or the smaller is the barrel, the more the surface area to volume ratio, and the better is the whiskey in the end. And you cannot see in those examples that some molecules from the barrel itself react with the hosts, but there was actually such example published very recently in Nature Chemistry. In this work, the researchers build molecular barrels from chiral building blocks. These two pyramids are exact mirror reflection of each other. This is an X-ray structure of one of the cages. In the next step, they add fullerene, which goes inside the cage. And on the next step, they react the cage with the fullerene inside, and after removing all the unnecessary parts of the cage, they end up with modified fullerene. These are enantiomeric molecules. On each of them there is 6 chiral centers. And making chiral fullerenes is a pretty hard task. Those molecules are needed for some applications in optoelectronics, and in order to make a pure chiral fullerene, you need to do very complicated reactions and very torturous isolation with chiral chromatography. In this case, no chromatography is needed, and you get 6 chiral center in one reaction. That's what I call a whiskey aging. Because the molecules from the barrel walls enter the barrel content and make it much more valuable. I hope you liked this video. Please like, share, subscribe, and support Ukraine. Have a great day.
As I was going over the far-famed mountains, I met with Captain Farrell and his money he was counting. I first produced a crystal and I then produced a mirror. So stand and deliver, for you are a bold deceiver. Mushering dum-a-doo-dum-a-da. Whack fall the daddy-o, whack fall the daddy-o, there's whiskey in the jar.